Welcome back to part 5 of this series that is looking at integration. In this video, we're going to look in particular at the integration of the exponential function, or the function e to the power of something. So we've got a rule over here where we have the integral of e to the power of ax dx is going to equal 1 divided by a times e to the power of ax plus c. So the more of these rules that you will encounter, the more you'll see that really all of them are just describing the opposite of differentiation. So when you differentiated an e to the power of ax function, you got ae to the ax. And now when you integrate, instead of multiplying by the a, you're now going to divide by that coefficient of x. So first up for question 1, I'm just going to rewrite this slightly. So we have the integral of negative 2e to the power of 3x. I'm just going to keep that, so minus 2e to the power of 3x. But here, instead of having plus 1 over e to the power of x, I'm actually going to write this as plus e to the power of negative x. And we're going to integrate all of that with respect to x. So now that we've got it in the form e to the power of ax, we can just apply this rule. So in our next line, this is going to equal. And the integral of negative 2e to the power of 3x is going to be minus 2 will stay there. It's multiplying the function, so it will also multiply the integral. So we have minus 2 times e to the power of 3x, and we divide by the new power of 3. And then for this one, we have plus, and we're going to divide by the coefficient of x, which is negative 1. So we're going to have 1 divided by negative 1, e to the power of negative x. And then, of course, we have that plus c, which is the constant of integration. So just cleaning this up slightly, this is going to equal minus 2 times e to the power of 3x divided by 3. And then this will just give minus e to the power of negative x plus c. So that is an appropriate answer for part 1 of this question. You could also have expressed this term as 1 divided by e to the power of x, using that negative power there to put it into the bottom line of a fraction. But we can leave it like that. So for part 2, we're going to again use our knowledge of integration, but now we're going to apply it to a definite integral, or one where there's terminals. So to evaluate this, the first thing we want to do is find the antiderivative of 6e to the power of 2x plus 5. And we'll put that in square brackets. So we'd have 6 times e to the power of, and it's still going to be 2x, and then we divide by that 2. So hopefully you follow along if I say that that's just going to equal 3e to the power of 2x when we antiderive that term. And then a constant like this, plus 5, is going to become plus 5x. We just multiply by the variable we're integrating with respect to. And then we're going to evaluate that between the terminals 0 and 2. So if I put those there, we can keep track of that. And then we have a theorem that says we can evaluate this by evaluating the antiderivative at 2, subtract away the antiderivative at the lower terminal of 0. If we go ahead and do that, and just make sure you place brackets in the correct spots here, we have 3e to the power of 2 times 2 when we sub 2 into this. So that will give 3e to the power of 4. So again, that's 2 times 2. Wherever there was an x, we're replacing it with 2. Plus 5 times 2, which is 10. And then we're going to subtract away from that. And when we sub 0 into this, we're going to have 3e to the power of 2 times 0, which is just 3 times e to the power of 0. So I'm going to write that down. And then we're going to have plus 5 times 0, which is simply 0. And now we're pretty close to answering this question. We'll just have 3e to the power of 4 plus 10. So that's our first bracket. And then we're going to minus away. And remembering that anything to the power of 0 is simply 1, this will just be 3 times 1. So we're going to subtract 3. So the value, when we evaluate this definite integral, is 3e to the power of 4 plus 7. So that's the answer to part 2 of this question. So once again, I hope this has helped, and make sure you check out the links below for similar questions to this if you need to see more examples, and stick around for part 6, where we're going to look at integrating circular functions.